Hello everyone. In today's lecture, we are going to learn about deadlock prevention in operating system. Now, what is deadlock prevention? What is the meaning of prevention? Prevention means preventing something before it occurs. For example, if you have a fear of getting cold, so first only what you will take the precautions or try to prevent it. Okay, by not eating any cold stuff. That is called as prevention. You are preventing first only before it can occur. Okay, now what is deadlock prevention? It ensures that system will never enter a deadlock state. Now what do you mean by deadlock state? Now this is a printer, consider it as a resource, and this is a process which is running on your computer, that is Word document, and you want to print this Word document, but Word document is infinitely waiting for this printer to get it print. I have given the print command, but already printer is printing many other things and it is not able to print, and it is waiting suppose infinitely. It is suppose got hanged, printer got hanged, or some problem became with the printer, and printer is not able to print the Word document. So Word document is a process which will wait infinitely for this resource, that is printer. So when this type of situation occurs, we call it as what? Deadlock. So in order to prevent the deadlock, so that deadlock will never occur only, we need to negate one of the four necessary conditions of deadlock. There are four necessary conditions that occurs, then only we call it as a deadlock. So which are the four necessary conditions? One is mutual exclusion, second one is hold and wait, third is no preemption, and fourth is circular wait. So these four condition has to occur together. When this four condition occurs, then only we call it as a deadlock has occurred. So what is deadlock prevention? We have to make sure any one of these conditions should get failed, or all can become false, but at least one should be false out of this. If we can make at least one false out of four, then we can prevent the deadlock. How we can make them false? So we'll see one by one how each one of them can be made false, or it is not possible to make them false. That we will see next. Now, example of mutual exclusion condition we are trying to make false. Okay, four necessary conditions are there for deadlock to occur. First necessary condition is mutual exclusion. If this occurs, then we can say what? Deadlock has occurred. This is one of the necessary condition of deadlock. So we have to try to make this mutual exclusion condition false. So you have to use the shareable resource. For example, this is the resource printer, and these are the processes. Word is process 1, suppose PowerPoint is process 2, Excel is process 3, Microsoft project is process 4, and Microsoft Visio is a process 5. So these are the 5 processes which are currently running on, suppose, your computer system. All are open and you want to print all these documents. Microsoft Word document also, Microsoft PowerPoint document also, Microsoft Excel document, Microsoft project, and Microsoft Visio. Some content is written in each of this document and you want to print each of them. Okay, but what will happen? Printer is not shareable. This resource cannot be shared by multiple processes. Mutual exclusion meaning is what? Resource cannot be shared. Okay, if the resource cannot be shared, then only we can say what? Mutual exclusion has occurred. So we have to make this condition false. Okay, false means what? We have to make the resource shareable, but resource like printer cannot be made shareable. So we cannot make mutual exclusion condition false, because at a time this resource will be used by only one process. All 5, even if you have given for printing, it will only print one process data at a time. That is, suppose Word, you have given the command for all 5, but first it will finish Word, then it will go to PowerPoint, then it will print the Excel, then after completing the Excel, Microsoft project, and then Microsoft Visio. It won't be shared. One will be completed first, then only it will print the data of next process. So first it will do the task of Word, then PowerPoint, then Excel process, then project process, and then video process. So printer cannot be shared. So mutual exclusion condition you cannot make false. It will occur only because some resources like printer, tape, drives cannot be shared. So it is impossible for practical system to make mutual exclusion condition false. Next is hold and wait condition. We have to make false. Now what is hold and wait condition? The meaning of this is what? One process is holding the resource and it is waiting for another resource which is held by some suppose other process. So process 1 is holding one resource and it is waiting for other resource. So it is holding and waiting. Okay, so we have to make this condition false. Meaning what? We have to condition false means what we have to do? We have to pre-allocate. That is all the required processes to request resources before starting process never has to wait for what it needs. So what process 1 has to do? In this case, before starting the work like printing or whatever, so this process has to request all the resources which it will need. Resource 1 suppose it needs, resource 2 it needs, resource 3 it needs. Before starting its execution or work, it has to request these resources in advance and it should tell operating system to give me these resources. Okay, so process will never wait for any resource because first only before starting he has requested and got all the resources which he needs. So process must give up all the resources and then request all immediately needed. After its work is done, this process work is done, it has to release all these resources so that it can be used by some other process. Together only he has to release, and if he wants together only he has to acquire or request before starting its execution. So now the problem with this technique is what? You may not know in advance how many resources you will need at the start. Now suppose I am cooking something. Initially I don't know how many. I am looking on the YouTube video and I'm doing some dish. So initially only I won't know what ingredients I will need for preparing my dish. So first only I cannot keep all the requested resources. So low resource utilization, even if it becomes possible, low resource utilization, many resources may be allocated but not used for a long time. Similarly, starvation will become. Now what is the meaning of starvation? Processes will wait for a longer time to get the resource. Okay, so processes may have to wait indefinitely for particular resource. So it will go in starvation mode. Then third condition is no preemption condition. What is the meaning of no preemption? Meaning when if a process is holding some resources and request another resource that cannot be immediately allocated to it, then all the resources currently being held are released. So preempted resources are added to the list of resources for which process is waiting. For example, this is a process 1 which is holding the resource 1, and he needs resource 2. Okay, holding and he wants resource 2 but it cannot be allocated suppose in because of some issue. So what will happen? Process 1 will release this resource 1 also. This resource 1 also it will release. Why? Because he cannot complete its task only. Because he wants resource 2 also, and resource 2 he currently cannot take it. So what he will do in that case? He won't keep resource 1 also holding. So he will leave resource 1 also. He will release resource 1 also. And both the resources will be added to the preempted list. Okay, resource 1 also and resource 2 also. So anybody can use those resources. These resources will be preempted. So we are making this condition false. That is no preemption condition false. So process will be restarted only when it can regain its old resources as well as the new ones that is requesting. So required resources are taken back from the process holding it and given to requesting resources. So what is the problem with this no preemption condition if you are making it false? Some resources like printer, tape drives cannot be preempted. Like one process is currently holding the printer resource, that document is getting printed. You cannot halfway it won't print one document and can go to the other document to print. It will finish that document only printing first. Okay, so printer cannot be preempted. Okay, so this condition also cannot be practically possible. You cannot negate this. No preemption, you cannot make this false completely. Same like mutual exclusion condition. Hold and wait is possible. You can make that condition false, but no preemption and mutual exclusion condition you cannot make false in all the cases. So in this case you may require job to restart like a printer. If you want to preempt it, you have to restart the printer. Then last condition which you need to make false in order to prevent the deadlock is circular wait condition. So how to make this circular wait condition false? You have to order the resources and each resource will be assigned one unique integer number and allows processes to request for them only in the increasing order. If process needs several instances of the same resource, it should issue single request for all of them. Alternatively, we can require that whenever process requests an instance of resource type, it has released all resources which are assigned smaller integer value. For example, now there are two processes in this, P1 and P2, and these are the four resources which are numbered in the increasing order. One is given to printer, 2 is given to scanner, 3 is given to CPU and 4th is given to register. Now P1 is holding the printer resource. Okay, process P1 like Word, suppose it is holding the printer resource and it wants to acquire CPU, that is resource number 3. It can acquire because what, this resource number 3 is greater than resource number 1, that is printer. Okay, 3 is greater than 1, so after taking 1 you can make a request for 3. Okay, so you have to request in the increasing order only. See, it allows the process to request for them only in the increasing order, then only you can make this circular wait condition false. Process P2, suppose it is PowerPoint document. Okay, when it goes to main memory, it becomes a process. So process P2 is currently holding the CPU resource. So it is currently holding the resource number 3. So what is written over here? Process has to request the resource in the increasing order only. So after 3, P2 can request 4 or 5 or 6, but it cannot request resource number 2 and 1. So now if the P2 tries to request resource number 1, that is printer, it cannot be done. Why? Because the number of the CPU resource is 3 and the number of the printer resource is 1, which is smaller than 3, and you have to request always in the increasing order resources. That's why resources are numbered 1, 2, 3, 4. So P2 has already taken CPU, that is resource number 3, so he can only request resource number 4, 5, 6 like that. He cannot request resource number 1 because it is smaller than resource number 3. So this cannot be done, this is wrong. Okay, you cannot, P2 cannot request resource number 1, so it is not allowing you to make cycle. So cycle is not formed, okay, or loop is not formed, so circular waiting is avoided in this. So circular wait condition you have to make false like this, then only you can prevent a deadlock. Now what is the problem with this? Adding a new resource that upsets the ordering requires all code ever written to be modified. Okay, you cannot actually request the resources in order. This is also not possible practically because after taking the CPU you might need printer, and printer is resource number 1 and CPU is resource number 3. So you cannot, according to this condition, if you try to fail, cannot acquire that resource number 1 printer again. Okay, which is not practically possible. So if you are adding any new resource that upsets the ordering request, you need to write the whole code again. So resource numbering affects its efficiency. Your system won't work properly because of this numbering system which you have done for your resources. So process may have to request resources well before. First only all processes has to request the resources before it needs it, like CPU, printer, RAM, everything has to request first only before even using it. So just because of the requirement that it must request resources in the ascending order. So these are the problems of making circular wait condition false. Now out of these four, only one is practically possible, that is hold and wait condition. You can make this condition false, but you cannot make mutual exclusion, then no preemption and circular wait condition false. This cannot be made false practically for all the resources. Okay, so what is deadlock prevention handling technique says? There are four deadlock handling techniques: deadlock prevention, deadlock avoidance, deadlock ignorance, and deadlock detection and recovery. We are learning only about the deadlock prevention in this video. So to prevent the deadlock, you need to negate or try to make any of the four necessary condition of the deadlock false. Any one or all four you can make false. Okay, hold and wait, mutual exclusion, no preemption, and circular wind. So we have seen how we can make them or cannot make them false and what are the problems associated if you try to make them false. About the deadlock prevention and the operating system. Thank you.